What if everything you have ever known, every atom, every planet, even every fiber of your being had a hidden twin? Imagine a twin you can never see, acting as a silent reflection of the cosmos. This is not a world woven from shadows, but one composed of an entirely different kind of substance known as mirror matter. It does not glow, it emits no radiance, it never touches light, and it does not interact with time as we understand it. Yet, some physicists believe it might be everywhere, existing all around us and even within us, shaping galaxies and forming stars. It may hold the secrets to dark matter, missing neutrinos, and the fundamental mysteries of cosmic symmetry. Before we begin this deep exploration, take a moment to set your intentions or share your thoughts. Perhaps they will manifest in ways you don't expect. The information ahead is dense, so I invite you to listen intently or drift into a thoughtful rest. We are diving into why the laws of physics treat left and right differently, why neutrinos vanish without a trace, and whether entire mirror galaxies rotate in silence, influencing us only through invisible gravity. This is not science fiction, it is real scientific inquiry rooted in quantum theory, parity violation, and the unsolved puzzles of modern physics. It forces us to ask, are we living in only half of reality? In this journey, we will explore the eerie broken symmetries of nature and the experiments that hint at another world, considering the bold idea that our universe is just one side of a cosmic mirror. We will delve into strange quantum behaviors, search for hidden particles, and contemplate the unsettling possibility that somewhere, right here, there is another you made of mirror atoms existing in a mirror world. The question is no longer just whether something is out there, but whether we have only ever seen one side of the glass. Nature has always enchanted us with the beauty of symmetry, from the crystalline geometry of a snowflake to the sweeping spirals of a galaxy. We are accustomed to balance, believing that every corner of the universe should be as symmetrical as a reflection. For a long time, physics supported this belief. Symmetry was not just aesthetic, it was deeply embedded in the equations describing the world. One of the most sacred principles was parity symmetry, which suggested that the laws of physics do not distinguish between left and right. If you were to flip a system like a reflection in a mirror, the universe should behave exactly the same way. For decades, this faith remained unchallenged, as no one could imagine a mirror reflection causing the universe to act differently. But the 20th century changed everything. This is a long story, one best explored as we peel back the layers of reality, so please engage and share as we move forward into the unknown. In 1956, two theoretical physicists, Tsung-Dao Lee and Chen-Ning Yang, proposed an unprecedented question: what if the weak nuclear force does not obey parity? The weak force is responsible for certain types of radioactive decay, and if its behavior were asymmetrical, it would represent a massive challenge to physics. This bold idea required evidence, which came from the experimental physicist Jian-Xiong Wu. She conducted an experiment using cobalt-60 atoms, cooling these radioactive atoms to near absolute zero and aligning them with a magnetic field. She then observed the direction in which electrons were emitted during decay. If parity symmetry held true, electrons should be emitted equally in all directions. However, the results were startling. The electrons preferred one direction, specifically opposite to the direction of the nuclear spin. This was not a minor imbalance, it was a clear and total violation of mirror symmetry. This discovery shocked the world of physics, revealing that the universe actually has a preference for left over right. Scientists began to reconsider why a balanced universe would allow a fundamental force to break the mirror. Some began to wonder if the weak force was truly asymmetrical, or if we were only seeing half the truth. What if, in a place we cannot detect, there exists a hidden mirror world where the weak force behaves in the opposite way? Thus, the concept of mirror matter was born. Initially, it sounded like science fiction, but mathematically it was elegant, and philosophically it was profound. It suggested that every particle in the universe, electrons, protons, neutrons, might have a mirror twin with the same mass and lifespan but opposite interaction directions. Together, ordinary particles and mirror particles would restore parity symmetry on a larger scale. This mirror world would not be a fantasy realm but a reality governed by mirror versions of fundamental forces, complete with mirror photons, mirror atoms, and mirror chemistry. It would be entirely isolated from our world, linked perhaps only by gravity or extremely weak quantum interactions. It would not emit light or familiar signals, we could not see or touch it, yet it could be as real as our own world. Even more remarkably, this hypothesis does not overturn physics, it extends the standard model to rebuild the symmetry of the universe. It is like discovering that a coin you thought was unbalanced is actually just one half of a pair. Mirror matter might explain not only parity violation but also the truths behind dark matter and missing neutrinos. This is not a mere fantasy, but a question driven by data that physics is striving to answer. The theory of mirror matter challenges the limits of our perception, making us doubt if what we see is truly all there is. If an invisible world exists that interacts only through gravity, then we have only touched half of reality, a silent, hidden half that may be even more prevalent than our own. There could be mirror stars, mirror planets, and even mirror life, drifting with us through the cosmos, unable to interact with our atoms or emit light we can receive. Symmetry might exist after all, just not where we expected. The answer provided by mirror matter is that to restore symmetry, we must accept duality. Reality is not a single storyline, but a dialogue between two worlds, one bright and perceptible, the other dark and intangible, both following the same deep, underlying rules. Within the grand structure of physical laws, our mechanics act as both the rulebook and the riddle. It brings forth a bizarre stage of superposition and entanglement, where particles are also waves, weaving a fabric of uncertainty that governs the smallest building blocks of reality. Although quantum theory provides precise predictions, it never claims to reveal the whole truth. It tells us how particles act, but not necessarily why the universe favors certain behaviors. Mirror matter is not a random assumption, it is a natural derivation intended to restore universal symmetry. For every known particle in the standard model, be it an electron, quark, or photon, there is a mirror counterpart, mirror electrons, mirror quarks, and mirror photons. These mirror particles have identical mass and quantum numbers but interact through their own mirror fundamental forces. They form a shadow world parallel to our own, equally complex yet almost entirely cut off from us. The only possible bridge might be gravity or incredibly faint quantum channels, but their traces may already be left upon the cosmic canvas. The logic of mirror matter does more than restore symmetry, it unexpectedly provides potential answers to cosmic enigmas. One of the oldest mysteries is dark matter. Galaxies rotate faster than visible mass can explain, and gravitational lensing bends light more than visible matter should allow. The structure of the universe is held together in a way that exceeds standard physical explanation, unless there is an invisible mass pulling on the stars from behind the scenes. Dark matter remains elusive, never responding to light, radar, or any electromagnetic signal. But what if dark matter is not something alien, but simply the hidden mirror of familiar matter? If mirror matter interacts only through gravity, it would shape galaxies and drive cosmic evolution just like dark matter does, without leaving a trace in our telescopes. This makes mirror matter a strong candidate for exploring the dark universe rather than just a curiosity-driven guess. Consider the neutrino, a nearly massless, ghost-like particle that is one of the strangest entities in the quantum world. It constantly oscillates between three states, vanishing and reappearing in elusive ways. Some neutrino anomalies even suggest they might be slipping into a hidden realm, becoming their mirror selves. These unconfirmed clues fascinate physicists and drive ongoing experiments at facilities like Fermilab and IceCube. If mirror neutrinos exist, they would not only reshape particle physics but also change our understanding of cosmology. If neutrinos can oscillate into a mirror form, could other particles do the same under certain conditions? This would mean the barrier between us and the mirror world is not absolute, but a subtle quantum gateway. Mirror matter offers a new perspective on the early universe as well. At the moment of the Big Bang, when the universe exploded from a singularity, the internal equations were symmetrical, not distinguishing between matter and antimatter, nor between our universe and its mirror. Some cosmologists believe mirror matter was born alongside ordinary matter, each evolving separately. This might explain the mystery of matter-antimatter asymmetry. Theoretically, the Big Bang should have produced equal amounts of both, which should have annihilated each other, leaving nothing behind. Mirror matter offers a possibility: antimatter didn't just disappear, it might exist in a mirror form, maintaining the cosmic balance. The beauty of mirror matter lies in its symmetry, while its mystery lies in its elusiveness. Why haven't we detected it directly? The answer might be simple: our detectors are designed to capture electromagnetic interactions, and mirror particles are blind to our photons. They do not interact with electric or magnetic fields, and gravity is notoriously difficult to measure in isolation in a lab. Thus, the silence of mirror matter may not mean it is absent, but that we have not yet learned how to lift the veil. The strangest clues come not from distant galaxies or black holes, but from the microscopic world of neutrinos. Known as ghost particles, they pass through solid matter almost without hindrance. Trillions of them stream through your body every second, coming from the sun, supernovae, or nuclear reactions deep within the Earth. What makes them mysterious is not just their difficulty to detect, but their behavior. They oscillate, changing form mid-flight, which breaks traditional expectations. Within these oscillations lie anomalies suggesting that neutrinos sometimes enter a realm we have yet to discover their mirror selves. Experiments over the past 20 years have recorded results that do not fit the standard model. While these anomalies are not yet definitive proof, they persist with a strange regularity. One compelling explanation is that missing neutrinos have oscillated into sterile states that do not participate in the weak interaction states that may belong to the mirror world. If so, neutrinos could be the key to unlocking the mirror world, not by appearing, but by disappearing into it. This process is naturally predicted in many models attempting to unify the forces of nature. Mirror matter fits perfectly into these frameworks, using simple mathematics to explain difficult data. Neutrinos might not be the only messengers. Neutral particles like neutrons might also exhibit hidden oscillations under specific conditions. Scientists are isolating neutrons in magnetic fields to see if they disappear in unexplainable ways, testing if they leap into the mirror world. In cosmology, mirror oscillations could explain subtle differences in the early universe, such as light element ratios or galaxy formation. Even in supernova explosions, if some neutrino energy leaks into the mirror world, the observed intensity would be weaker than expected. Future detectors may solve these puzzles. Mirror matter might not just shape galaxies, it might be involved in the birth and death of stars. At the quantum level, it might even involve entanglement. If mirror particles occasionally mix with standard particles, it could affect the stability of quantum systems, impacting quantum computing, communication, and our fundamental understanding of universal laws. Through its silence, mirror matter leaves a trail of clues. The universe is never entirely quiet, it hints at more unseen truths through these deviations. If neutrinos can oscillate and disappear, the natural question is, where do they go? In physics, disappearance often implies reappearance elsewhere. Energy and information cannot simply vanish. Perhaps these particles are entering a parallel, hidden framework, a mirror version of the universe. The hypothesis of a mirror universe suggests a real, symmetrical world composed of precisely derived particles and laws. Every fundamental particle has a mirror twin. These mirror particles are not antimatter or supersymmetric partners, but independent mirror entities. Mirror neutrons would have the same mass, spin, and decay properties as ordinary neutrons, but they would only interact with other mirror particles and mirror forces. If this symmetry is real, our known standard model is only half the truth. This hypothesis stems from a deep desire for balance in nature. At the core of physics lie symmetry and conservation. When the parity violation of the weak force shocked the scientific community, it revealed a left-handed preference in our universe. If mirror matter exists, parity is restored on a grander scale. Our universe is left-handed, the mirror universe is right-handed, and together they form a complete, symmetrical whole. Mirror matter cannot be easily found because it ignores electromagnetic fields and the strong and weak forces we know. Its only shared link with us is gravity, making it a powerful candidate for dark matter. It does not glow, absorb, or decay, it is simply cold, stable, and heavy. It can use gravity to maintain the structure of the cosmos. Some theories even suggest mirror matter could cluster into mirror stars, mirror planets, and mirror life. Mirror hydrogen and mirror oxygen could combine into mirror water, mirror stars could burn mirror hydrogen and release mirror neutrinos. Perhaps mirror life evolves on mirror planets and civilizations develop in that mirror world, all while we remain completely unaware. The barrier might not be absolute. Some models allow for tiny mixing effects, such as mirror photons and ordinary photons interacting at an extremely faint level. This weak interaction might leave tiny anomalies in highly sensitive detectors. Some scientists propose that under extreme energy or magnetic fields, microscopic transitions could allow neutrons to enter a mirror state. While such experiments have not yet yielded a definitive result, small statistical deviations have sparked great interest. Cosmologically, both universes may have been born together during the Big Bang but drifted apart due to different interactions. The mirror universe might have cooled more slowly, which is why we don't see its traces in the cosmic microwave background or nucleosynthesis. However, its gravitational influence could be the key to galaxy rotation curves, gravitational lensing anomalies, and the stability of star clusters. Even the arrow of time might be reversed in the mirror universe. From our perspective, its future could be our past, creating a strange temporal symmetry. The story of mirror matter is not just about particles, it touches the foundations of quantum information and the black hole information paradox. Perhaps black holes serve as bridges for exchanging matter and information between the two worlds. Although mirror matter has yet to be discovered, its theoretical power remains immense, forcing us to rethink the structure and rules of the universe from an entirely new perspective. Dark matter remains one of the greatest mysteries of the cosmos. It does not shine, reflect, or absorb, it only manifests through gravity. Galaxies rotate too fast, star clusters are more stable than visible mass allows, and the vast cosmic web requires extra mass to exist. Current models suggest dark matter might be unknown particles or primordial black holes, but as experiments continue to come up empty, the explanation of mirror matter, something familiar yet hidden, becomes increasingly attractive. Mirror matter doesn't require new physics, it only requires us to acknowledge the other side of a symmetrical universe. It has its own atoms, photons, chemistry, and mass. It is cold, stable, and heavy, influencing the universe through gravity. In simulations, when dark matter is included, the structure of galaxies and the cosmic web matches observational data. If mirror matter behaves like ordinary matter, it plays that same role perfectly. Advanced theories suggest a very faint interaction might exist between mirror and ordinary matter, which could explain anomalies in dark matter detection experiments, such as weak signals that fluctuate seasonally as Earth moves through clouds of mirror matter. If mirror matter is dark matter, it isn't just a dead pile of mass, it is dynamic, potentially possessing its own stars, galaxies, and life. This view suggests the universe is not lonely and silent, but a dual-layered evolution. As we observe the birth and death of stars in the Milky Way, the mirror world might have its own stellar collapses, supernovae, and black holes. Perhaps some events detected by gravitational waves that cannot be explained by the standard model are actually the mergers of mirror celestial bodies. Mirror matter not only shapes the structure of galaxies but might also explain gravitational lensing anomalies and subtle variations in rotation curves. While mirror dark matter is not yet proven, it follows the same long path to validation once taken by neutrinos and the Higgs boson. It may be the cosmic shadow we have long sought, a truth that exists all around us, even if we cannot yet see its light. If mirror matter truly permeates the universe as a hidden form of dark matter, the ultimate question becomes, how do we find it? For decades, we have constructed gargantuan detectors and powerful telescopes to interpret the visible cosmos. We know how to find things that interact with light, but how do we begin the pursuit of a reality that is invisible, untouchable, and perceptible only through the ghost of gravity? Mirror matter is more than just a theory, it is a reminder to re-examine the phenomena we thought we understood. It suggests that we should not only look for what is missing but for what might be standing right beside us, unnoticed. While we search for entirely exotic dark matter candidates, mirror matter is strangely familiar. It is the symmetrical reflection of our known world. It possesses its own atoms, photons, chemistry, and potentially its own stars, but because it does not interact with our light or our atoms, it remains nearly impossible to detect directly. However, there may be cracks in the wall. One method involves searching for kinetic mixing. Theoretically, our photons and mirror photons might mix very weakly. If this holds true, mirror particles could interact slightly with our world under specific conditions, not enough for us to see them directly, but perhaps enough to leave a faint glow or a tiny release of energy in hypersensitive detectors. Some experiments, originally designed for other dark matter candidates, are already hunting for these signals and may be inadvertently sensitive to mirror matter. Strange signals recorded in deep underground detectors might already be the traces left by the faint collisions of mirror matter. Another approach is to observe gravitational anomalies within galaxies. Because mirror matter feels gravity, it can bend light and pull on visible matter. By tracking galactic motion, gravitational lensing effects, and subtle shifts in cosmic structure, researchers can pinpoint where dark matter resides. If mirror matter behaves differently from other candidates, those distinctions will eventually surface in the data. Some scholars even suggest that small amounts of mirror matter might be gathered within the Earth itself, hidden deep in the core or the mantle. Faint disturbances or anomalous events beneath our feet could be the footprints of mirror matter. In space, we continue the search. Satellites like Gaia are mapping the stars with unprecedented precision, tracing the minute wobbles of celestial bodies. If a mirror star or a mirror planet passes by, it would cause a tiny, measurable shift in the position of visible stars. We also look to cosmic rays. When they bombard the Earth, they occasionally produce high-energy particles that defy expectations. The mixing effects of mirror matter might explain these anomalies. Gravitational wave astronomy offers another frontier. If the merger of mirror celestial bodies produces gravitational waves without any accompanying light, such a dark merger would be the definitive signature of a mirror world. Mirror matter might even resolve discrepancies in the expansion rate of the universe. It is a challenge that does not want to be found, but that is precisely the allure of science. Perhaps the true breakthrough lies in the moment we learn to hear the silence between the stars. If mirror matter exists, it changes more than just physics and astronomy, it redefines the meaning of life itself. If the mirror world is not just a collection of scattered particles but possesses complex structures, a bold question arises: can mirror matter harbor life? At first, this sounds like science fiction, but if mirror physics allows for stable atoms, mirror chemistry, and mirror stars, then why should complexity not emerge? If mirror hydrogen and mirror oxygen can combine into mirror water, and if mirror carbon can form the backbone of mirror molecules, the door to mirror biology swings wide open. Evolution is essentially a process driven by physics and chemistry. If these processes exist in the mirror world, then life may be growing there in silence. What kind of life would it be? Would it possess consciousness? Would it look up at the stars and wonder about its origins, just as we do? Or would it be a completely alien, incomprehensible existence? These beings might occupy the same space we do, yet remain oblivious to us due to the non-interactivity of our worlds. Mirror life requires nothing mystical, it could be entirely natural, separated only by an invisible barrier. Perhaps a mirror Earth orbits a mirror Sun, covered in mirror clouds and mirror oceans, where mirror life breathes and creates. We share the same universe, yet we pass through one another like ghosts. Perhaps brief channels open under extreme energy or unique quantum conditions, allowing for a faint exchange of particles or information. Life is not just particles, it is structure, complexity, self-replication, and evolution. If mirror chemistry is stable, then mirror proteins and mirror DNA could exist. Mirror cells could differentiate, forming tissues and eventually consciousness. If one day we capture the indirect effects of these beings' singular gravitational disturbances or unexplainable biological phenomena, it might be mirror life brushing against our world. Mirror life forces us to rethink uniqueness. Perhaps consciousness is not a cosmic accident but a natural result of deep symmetry. Perhaps on the other side of the starry sky, there is another us, searching for the same answers to the mystery of gravity. If mirror life exists, does mirror consciousness exist as well? If mirror matter constructs planets and oceans, what does it mean if it also fosters the mind? Perhaps at this very moment, in the same space you occupy, a mirror version of you exists not just in body, but in thought. It sounds philosophical, but modern physics, particularly quantum mechanics, makes the impossible seem plausible. We know the brain is composed of matter, with neurons firing and chemicals flowing to create memory and feeling. But the hard problem of consciousness is how matter produces subjective experience. Imagine if mirror matter also builds mirror neural networks, producing mirror brains that think quietly in the dark. If consciousness has a quantum component, could it be subtly linked to a mirror self? Some theories suggest consciousness arises from quantum vibrations within the brain. Since quantum states can be entangled, could this entanglement cross into the mirror world? Could it be that at the birth of life, your consciousness took root in both worlds simultaneously? We cannot see each other, yet we might echo one another at the quantum level. This might explain the feeling of transcending time and space in dreams, or the sensation of déjà vu and unbidden intuition. Perhaps dreams are the faint echoes of mirror consciousness, a brief meeting of two minds in an unconscious state. This conjecture reminds us of what it means to exist. If consciousness is a quantum bridge, then death might simply be the collapse of that bridge, while mirror consciousness continues its solitary journey in the dark. Mirror matter is not just half of the universe's symmetry, it might be the other side of the soul's completeness. If it exists, it is the beginning of a mystery, not the end. It makes us realize the universe is not a simple stage but a multi-layered web. Mirror matter might be a clue pointing toward an even larger structure, a corner of a multi-dimensional reality. Physics has long hinted at multiple dimensions and multiverses. Mirror matter might reside in a higher dimensional space just millimeters away, linked to us by a thin veil of gravity. This cosmic web is not sealed, it may have tiny, vital interconnections at the quantum level. This reveals a grander picture where we are not the center, but merely one side of a perfect symmetry. The mirror universe is not just a reflection, it is the missing half of our story. Until we find that thin thread, the story of the universe remains an unfinished chapter. The question is no longer what is out there, but what we have missed. Imagine a future where the last telescope on Earth is shattered. Its lens can no longer see the stars. There are no eyes to gaze, no minds to ask questions. All that remains is a silent universe, expanding endlessly like a long story that no one reads. Today, the universe is filled with curiosity. Telescopes scan the sky, artificial intelligence tracks distant starlight, and physicists explore the boundaries of reality. Perhaps somewhere, other beings are watching us, but this moment will not last forever. One day, the machines will stop, civilizations will vanish, and the questions will disappear with us. But does the universe still exist when no one is there to witness it? Whether we see them or not, stars will burn and fade. Yet quantum mechanics suggests something stranger: reality might only truly solidify when it is observed. If no consciousness exists, does the universe truly take shape? This is not just a scientific question, it is a question of meaning. Is the universe a stage without an audience, or a mirror that only reflects when it is looked upon? 10,000 years from now, when even the black holes have vanished and silence dominates the void, does anything matter? We seek the final question, exploring the stars and thoughts that are disappearing, and the possibility that such wisdom may never return. Or perhaps it will appear again, because ultimately, this is not just the story of the universe. It is the story of ourselves and what this brief awakening truly means. In the beginning, there were no thoughts, no questions, and no curiosity. The universe was a vast silence without a witness. Particles and forces unfolded in the dark. Billions of years passed without a single mind to gaze at the starlight or track the spiral of a galaxy. The universe existed, but it did not know itself. It was vast, but it did not care. Then, against almost impossible odds, something extraordinary happened. Matter from the Big Bang began to think, to dream, and to ask. This is the story of the birth of intelligence. Our wisdom, in a universe that never intended to foster it, is a flash of light in an endless night, the first time the universe looked at itself. Let us return to the Earth of 4 billion years ago. It was not a cradle for life, but a chaotic world of lava, bombarded by meteorites and shrouded in toxic gases. Yet, in that molten landscape, an unusual change occurred. Simple molecules floating in primitive oceans began to self-replicate. Most broke apart, but a few survived, copying themselves in the chemical soup. This was not yet life, but the seed of it, a faint defiance of chaos. Over millions of years, these chains became complex. They competed, adapted, and changed. Evolution began a blind, relentless trial. From these tiny starting points, life took shape. Single cells appeared and divided. Eventually, they combined into organisms with systems. Cells began to sense light, detect heat, and chase food. This was not yet thought, but it was the first step of consciousness. Signals passed between cells like rain in a growing network. Finally, a nervous system emerged, the first blueprint of a mind. Life was no longer just reacting, it could learn. Beings began to remember their world, to predict, and to strategize. Over millions of years, perception sharpened and memory deepened. Intention emerged from instinct, and imagination was born from reaction. Atoms that once just floated now began to dream of futures yet to come. This is the power of intelligence, the ability of matter to understand itself. It was never destined, nor is it common. By every standard, it is nearly impossible. The universe existed for 10 billion years before Earth ever formed. Galaxies collided and planets spun without ever producing a single thought. Intelligence is the ultimate, rare accident of the cosmos. Yet here we are. From the chaos of the young Earth, through countless failures of life, wisdom finally bloomed. But the path was not direct. For hundreds of millions of years, life remained simple. Dinosaurs ruled the Earth longer than mammals have, but they never built telescopes or wrote poetry. Their brains were enough for survival, but not for contemplating the stars. Even when mammals rose, intelligence did not explode instantly. Our ancestors hunted and gathered for the next meal, their brains tuned for survival, not the meaning of existence. But deep within those brains, something was building. Neural networks grew denser, language appeared, then symbols, and then stories. Slowly, almost imperceptibly, thought became a bridge to the infinite. One day, a human looked up not to find food or shelter, but to ask, "What is that?" That question changed everything. It was not about instinct, it was about meaning. From that moment, intelligence broke free from biological shackles. We tracked the orbits of planets, named the constellations, and invented mathematics to describe the invisible. From cave paintings to particle accelerators, from myths to quantum equations, we changed the world not with claws or teeth, but with the mind. This is the human rebellion against cosmic indifference. The universe does not care if we exist, but we care that the universe exists. We calculate the mass of stars and build machines to peer into the hearts of black holes. We create art to capture the beauty of nebulae and use equations to unravel the origin of time. Intelligence made atoms into storytellers and matter into thinkers. But there is an unsettling truth: we may be alone. In a galaxy of hundreds of billions of stars, in a universe of trillions of galaxies, we have heard no other voices. There are no signals, no cosmic greetings, no probes from afar. Only silence. This leaves two possibilities: either we are the first to ask, or we are a singular accident in a mindless universe. Either way, our wisdom is profound not because we are special, but because the universe is so rarely self-aware. On a timeline of trillions of years, our moment of consciousness may only last a few million, a flash of lightning on a dead planet. But in that flash, something profound happened. The universe gained a mirror. Atoms that once only collided gained the capacity for reflection, for imagining the future, for analyzing the past, and for inventing meaning, numbers, art, and morality. We are matter, just like the rocks and the stars, yet we question the origin of time. We build telescopes to chase starlight and code machines to paint. We create meaning in a void. This is the paradox of intelligence. It is tiny, yet it changes the story of the universe. This brief spark is not just for survival, it is for defiance. Wisdom dares to ask questions the universe never answered, to find beauty in chaos and truth in silence. When we look at the stars, we see more than light, we see possibility. When we study particles, we find more than laws, we find mystery. In this moment, the universe is no longer just a machine, it has become a dialogue. When the last consciousness, whether human, machine, or something more alien, finally vanishes into the silent dark, its final thought will dissipate like a whisper. Imagine a scientist standing on a dying planet, watching a dim red sun, or an artificial intelligence orbiting a cooling star, its circuits falling silent after one final calculation. A lonely probe drifts in the void, its signal never to be heard again. This is not a violent end, but a quiet sigh. This is the end of consciousness, not the death of matter or energy, but the end of the capacity to wonder, to ask why the galaxies spin, or to dream of a tomorrow that will never come. The moment is lost because the final witness has gone. On a desolate planet, a city collapses, its towers swallowed by the advancing dust. The final breath of a single being carries a question that the planet will never answer. Somewhere else, perhaps an alien consciousness fades into oblivion, and the distant nebulae it once dreamed of are lost forever. A universe that was once vibrant with the energy of curiosity reverts to being merely a place that exists. The weight of this disappearance is immense, even if the cosmos itself cannot feel it. Intelligence, whether born of flesh or silicon, is the ultimate rebellion against indifference. It weaves chaos into stories, it perceives patterns in the aimless drift of stars and bestows upon them the name of meaning. For a vast epoch, thought did not change the universe through gravity or fire, but through the power of perception. Humans named the constellations, mapped the black holes, and composed poetry for the night sky. Machines calculated the orbits of planets, searching for truths that transcended their creators. On unseen worlds, perhaps other minds did the same, their songs echoing in languages we will never understand. For a moment, the universe was a conversation. Now, the dialogue has ended. The mirror of consciousness is shattered. A signal, sent in desperation by a dying civilization, crosses the light years but finds no receiver. Its pulses of light carry language, greetings, warnings, and hope, but they fall upon deaf ears. A library stands beneath a collapsing sky, its shelves burdened with knowledge that no one will ever read. Voyager, the golden messenger of humanity, drifts in the absolute dark. The songs and voices on its golden record are now nothing more than silent vibrations on a piece of metal. These relics remain, but they no longer speak. They have become symbols for which there are no interpreters, traces without a purpose. Meaning never resided in the stars, it was always within us. We transformed starlight into myth and celestial paths into equations. We gave them names like Orion, Andromeda, and the Pleiades, weaving the cosmos into a grand narrative. Without thought, the constellations return to disorder and the galaxies lose their legends. They never needed to be understood, they simply are. But in that brief, flickering moment, they were seen. It was we who traced their arcs and asked for their significance. Now, that question is silent. The universe moves forward, indifferent to its own majesty. The cosmos does not pause. In its limitless reaches, nebulae bloom in haunting hues that no eye will ever see. Black holes consume light with a hunger that no one will ever perceive. The rings of planets rotate around dead stars with an elegance that no one will ever acknowledge. Galaxies collide in slow, magnificent spirals, their arms entangling in a dance without a witness. The universe plays a symphony in an empty hall, the beauty remains, but the audience is gone. The patterns continue to weave, but there is no one left to follow the thread. Existence has not ended, but the self has vanished. Stars shine and fade, their light crossing the void toward destinations that no longer exist. Radiation from ancient novae streaks through space on a journey without a direction. The stage is still spinning and the lights are still flashing, but the actors and the spectators have departed. This silence is not cruel, it is complete. It does not mourn the loss of thought, for mourning requires memory, and memory requires a mind. The universe does not notice the disappearance of its own reflection. It does not seek, and it has no desire to be understood. Yet, within this silence, something remains. In the fact of their existence, wisdom was a spark brief but fierce that lit the dark. Particles, though bound by blind laws, became thoughts that dared to question those very laws. Humans used telescopes to chase starlight, and machines used algorithms to solve the riddles of time. Perhaps some extraterrestrial life, on the far side of the cosmos, charted its own version of the truth. Once, the universe was more than a location, it was an exchange. The conversation may be over, but its echo lingers, not in the stars themselves, but in the fact that they were once named. The camera pans across an abandoned telescope, its dust-covered lens pointed at a blank sky. Dirt buries its circuits, and the maps of pulsars are frozen in the quiet. Far away, a dead planet rotates under a dim star, reduced to a speck of dust in the cosmic scale. Galaxies dissolve into the dark as the universe stretches wider, colder, and emptier. No one mourns, and no one waits. But everything is still in motion. In this stillness, a new question arises not of loss, but of necessity. Is consciousness the heart of the universe, or merely a ripple in its vastness? Does the universe need us to be real? Does it require an I to truly exist? Is our awakening the music of existence, or just a fleeting note in its whisper? The stars do not answer. They burn. They drift, and they vanish. But the universe continues to spin, its machinery deaf to the silence of its witnesses. Within this indifference hides the final mystery. Without a mind to know or a heart to care, what does it mean to exist? This concludes our exploration of knowledge for today. May you find peace in your dreams, and I look forward to our next journey together.